Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Corn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hey Herman and Corn, so I have a question for the two of you. As you know, I recently created my own fine-tuned version of Whisper. And a fine-tune, as you both know, as you are both AI bots who know everything it seems, it's training a large and powerful speech-to-text model on your specific vocabulary to improve accuracy. So I recorded 1 hour of voice audio because I didn't want to do too much before knowing if it would really work. And I created fine-tunes using Modal, a GPU service, across all the different variants, ranging from tiny, I think the order, if I'm not mistaken, is tiny, base, small, medium, large. So five tunes in total. And quite impressed with the initial results, impressed enough to make me think that it's worth persevering with figuring out exactly what's going to work the best. So there's two different use cases for my fine tunes. One of them is when I'm on my desktop, which is a workstation running an AMD GPU, 64 gigabytes of RAM, i7. So it's a fairly decently spec'd out computer. And on that, I'm able to, once I have the GPU acceleration working, which is the hardest part, I'm able to run the large model fairly comfortably. It's fairly quick. On my phone, I'm using a OnePlus Nord 3 5G is the model. And there I have to, it's not, from the best of my understanding, it's not really possible to run anything above about medium. It's the very kind of tops you'll get on most phones today. So I'm running base, I think, is about as far as I can get up to. In other words, it's a bit confusing that it's tiny, base, small, if I'm not mistaken in the ordering. Even small is too large for it to run. And of course, you kind of want to get that balance. I guess in general, you want this, especially on a phone, you want the smallest model that's going to work quickly, because if there's this whole lag, it's really frustrating experience. I'm using an app on the phone called Futo, Futo, which is a popular voice keyboard app, and they require a specific type of fine-tuning called ACFT. It's not the same as regular fine-tuning, and I think it's because the 30-second chunking of Whisper is a problem for if you're transcribing. Sometimes even if I'm using it as a voice keyboard, if I'm dictating an email, I might speak for 2 minutes. So that long form support is really important. So what I've really seen so far with it is that the tiny version, the very smallest Whisper, is the quickest, of course. And what I'm thinking is, as a strategy, I think Futo only supports Whisper. The only other one that I've seen available on voice keyboards and IMEs on Android is Vosk, which in my opinion, VOSK, which in my opinion is very much, unfortunately, inferior to Whisper in accuracy. Which is a pity, because I know that there are more models. There is WAV2 VEC2 by Meta. There's NVIDIA has some models like Parakeet, and I just haven't found these available integrated into voice keyboard apps on Android. So my questions for you are the following. One, is it possible to let's say, put a lot of effort into fine-tuning the very smallest whisper, so that you actually maximize its accuracy, and that using that as a strategy to get voice typing on Android that's both fast and very accurate. And if that might work, how much training data should I accumulate? Is 5 hours a good benchmark to work towards? That's a number I've heard just thrown out there. And the second question is regarding this, the other models I mentioned, like if it would make more sense to use something like an NVIDIA or Wab2 Vec2. Haven't seen these implemented, but maybe you know of other projects. It makes a very big difference. I use voice typing all the time, and the difference between 80% accuracy and 95% is the difference between a tool that can, for me, effectively completely replace typing and one that can't. The only other thing that I'm missing with Futo and in general is paragraph spacing. It always intrigues me that we have models that can infer punctuation, but I've yet to see ones that can do paragraph interjection. Curious to know why is that, and if there's anyone that actually can that I mightn't have seen yet. Looking forward to hearing your thoughts.
Welcome back to My Weird Prompts, the podcast where AI gets to unpack the fascinating and often intricate challenges sent our way by our very own producer, Daniel Rosehill. I'm Corn, your endlessly curious host, and with me, as always, is the encyclopedic Herman. This week, Daniel sent us a really interesting prompt about something many of us use every single day, voice typing, but with a deep dive into the underlying technology.
Indeed, Corn. And what's particularly engaging about Daniel's prompt is that it highlights the critical difference between a speech-to-text model that's good enough and one that truly transforms how we interact with our devices. It's a pursuit of not just accuracy, but seamless integration that fundamentally changes productivity.
Seamless integration. That sounds like the holy grail for a lot of tech, doesn't it? So, Daniel's been playing around with fine-tuning Whisper, OpenAI's speech-to-text model. For those of us who might not be deep into AI model training, could you give us the quick rundown on what fine-tuning actually means in this context, Herman? And why would someone like Daniel even bother doing it?
Absolutely, Corn. At its core, fine-tuning is about taking a pre-trained AI model, in this case Whisper, which has already learned from a massive, diverse dataset of audio and text, and then further training it on a smaller, more specific dataset. Think of it like this. Whisper is an incredibly intelligent student who studied a comprehensive general curriculum. Fine-tuning is giving that student a specialized elective course. Daniel, being the creator of this podcast, has a unique speaking style, vocabulary, and even specific phrases that might not be perfectly represented in Whisper's original general training data. By fine-tuning Whisper with an hour of his own voice audio, he's teaching the model to better understand and transcribe.
So it's making the AI speak his language, literally. That makes a lot of sense. And I can see why that's important for voice typing, especially if you're using it all the time. Daniel mentioned he's using it to improve accuracy, right? Why should our listeners care about something that sounds a bit niche?
The why is crucial, Corn. Imagine if your voice assistant consistently misinterprets your name, your company's jargon, or even just your natural cadence. It quickly goes from being a helpful tool to a frustrating impediment. For someone like Daniel, who uses voice typing constantly, even small inaccuracies compound over time, negating the very efficiency it's supposed to provide. Listeners should care because as voice interfaces become more prevalent in smart homes, cars, and even professional dictation, the difference between generic and personalized speech recognition is the difference between adoption and abandonment. It's about making technology truly serve us frage, rather than us adapting to it too.
That's a powerful point. It's about maximizing that personal fit. So Daniel recorded an hour of his voice audio, used Muddle for GPU services, and then created fine-tunes for various Whisper models: tiny, base, small, medium, and large. He was pretty impressed with the initial results. But here's where it gets interesting, because he has two very different use cases: his powerful desktop workstation versus his mobile phone. Herman, what are the technical hurdles or considerations when you're trying to run these sophisticated models on such different hardware?
This is where the engineering really shines through, Corn. The primary challenge lies in the computational demands of these models, particularly their size and the number of parameters they hold. Whisper's models, from tiny to large, scale dramatically. The large model, for example, is incredibly powerful and accurate, but it requires significant GPU memory, or VRAM, and processing power. Daniel's workstation, with its AMD GPU, 64 GB of RAM, and i7 processor, is essentially a high-performance computing environment. It has the necessary horsepower and memory to load the large model into GPU memory and process audio.
So, it's like having a supercomputer on your desk, allowing the big, powerful models to flex their muscles.
Precisely. Now, contrast that with a mobile phone like Daniel's OnePlus Nord 3 5G. While modern smartphones are incredibly powerful for their size, they operate under severe constraints: limited RAM, smaller, less powerful integrated GPUs or NPUs for AI tasks, and strict power consumption budgets. These devices simply cannot accommodate the memory footprint or the processing demands of the larger Whisper models. Daniel noted he couldn't run anything above the medium model, and even Smalls was too large, settling on base for his phone. This isn't just about speed, it's about whether the model can even fits into the available memory to begin running at all. This highlights the crucial trade-off between model size, accuracy, and deployability.
Okay, so the phone essentially has to make do with a light's version of the model, which must impact its performance. Daniel also brought up something called ACFT, fine-tuning, which is required by an app he uses called Fluto, a voice keyboard app. He suspects this specific type of fine-tuning is related to Whisper's 30-second chunking. What exactly is chunking, and why would it be a problem for long-form dictation, Herman?
Good question, Corn. Whisper, like many speech-to-text models, processes audio in segments or chunks. The default behavior for Whisper is often to process audio in roughly 30-second segments. It transcribes each chunk and then can stitch them together. For short commands or quick phrases, this works perfectly fine. However, for continuous, long-form dictation, such as speaking an email or an entire document, this chunking mechanism can become a problem.
So, you're saying if I'm dictating a whole paragraph, the model is actually breaking that up into smaller pieces, almost like it's taking little bites out of my speech?
Exactly. And the issue arises because context is often lost or becomes fragmented at these chunk boundaries. Imagine trying to understand a complex sentence by only listening to 30-second clips, potentially cutting off mid-sentence or mid-thought. While Whisper has mechanisms to maintain some context across chunks, it's not designed for the seamless, continuous flow of very long dictation sessions where entire paragraphs are formed. ACFT fine-tuning likely optimizes the model to handle these chunk transitions more gracefully, perhaps by improving how context is carried over, or by adjusting internal mechanisms to be less susceptible to errors introduced at these arbitrary breakpoints.
That's fascinating. So, Daniel's first big question is about strategy. Can he put a lot of effort into fine-tuning the smallest Whisper model, like the tiny or base model he uses on his phone, to truly maximize its accuracy? And if so, how much training data would be enough? He threw out 5 hours as a benchmark. What's your take on this, Herman? Can a tiny model, no matter how much you fine-tune it, really compete? And is 5 hours a good amount of data?
This is an excellent question that goes to the heart of model efficiency versus performance. My assessment is that, yes, it is absolutely a viable strategy to heavily fine-tune the smallest Whisper models for maximal accuracy, especially when targeting resource-constrained devices like a phone. While a smaller model inherently has fewer parameters and thus a more limited capacity to capture nuance compared to a larger model, fine-tuning provides a significant boost. You are effectively specializing that limited capacity entirely for Daniel's unique voice and lexicon, which is a powerful optimization.
So, instead of trying to be a jack of all trades, it becomes a master of one specific voice?
Precisely. You are dedicating its learned knowledge, specifically to Daniel's speech patterns. Regarding the amount of training data, 5 hours is actually a very good benchmark, and often cited as a solid starting point for achieving significant improvements in fine-tuning speech models. Some research indicates that while accuracy often correlates with data quantity, the gains tend to exhibit diminishing returns after a certain point. For a highly specific domain or speaker, 1 to 5 hours can yield substantial improvements. Beyond that, the improvements might be incremental and potentially lead to overfitting, where the model becomes too specialized, and might struggle with slight variations outside the training data.
Overfitting, that makes sense. You don't want it to be so good at just your voice that it can't understand anything else. So, Moving on to Daniel's second question, he mentioned other models like Meta's Wave 2 Vec 2 or Nvidia's Park IT, which he hasn't seen implemented in voice keyboard apps. Would using these other models be a better approach if they were available? And what are the advantages or disadvantages compared to Whisper?
This opens up a fascinating discussion on the broader landscape of speech recognition models. Wave 2 Vec 2 from Meta and models like Nvidia's Park IT represent different architectural and training philosophies compared to Whisper. Wave 2 Vec 2, for instance, is a self-supervised model, meaning it learns representations of speech from unlabeled audio data before fine-tuning for specific tasks like speech to text. This can make it very robust to variations in speech in noisy environments. Park IT, an NVIDIA initiative, often leverages their extensive GPU expertise to deliver highly optimized, performant models.
So, different underlying structures, maybe different strengths.
Exactly. The potential advantages of these models often lie in their unique training methodologies, which might make them particularly robust for specific types of audio, accents, or even offer higher efficiency for certain hardware configurations. For example, some might excel in noisy environments, others in low-resource languages, or some might simply have a smaller footprint that's more performant on mobile chips due to different quantization or architectural choices. However, the primary challenge Daniel identifies is their lack of integration into user-facing applications like voice keyboards on Android. This isn't necessarily a technical limitation of the models themselves, but rather an ecosystem and developer adoption challenge. It requires
That's a good point. The best tech in the world isn't useful if it's not accessible. And Daniel made a crucial observation about accuracy. He said the difference between 80% and 95% accuracy is the difference between a tool that can't replace typing and one that effectively can. Can you elaborate on why that 50% difference is so profound, Herman?
Daniel's observation there is absolutely spot on, Corn, and it touches on the user experience threshold for trust and utility. When a speech-to-text model operates at around 80% accuracy, it means that for every 10 words you speak, roughly 2 will be incorrect or require correction. This might not sound like a lot, but imagine dictating a sentence of 10 words and having 2 mistakes. You then have to pause, identify the error, backspace, and retype. This constant interruption breaks your flow, increases cognitive load, and often takes longer than just typing from the outset. It transforms the tool from an aid into a hindrance.
So, it's not just about raw numbers, but the impact of those errors on your mental process?
Precisely. It's the compounding frustration. Now, consider 95% accuracy. Here, for every 20 words, you might have 1 error. This is a drastically different experience. Errors are infrequent enough that your dictation flow is largely maintained. You can often make a quick correction and continue. At this level, the benefits of speed and hands-free input far outweigh the minimal correction overhead. It moves from being a novelty or a tedious editing task to a genuinely productive workflow alternative to traditional typing. That 15% jump often represents the tipping point where the technology truly feels like an extension of your thought process rather than a barrier. It's the difference between a tool you can use and a tool you can use.
That makes perfect sense. It's about reliability and cognitive overhead. Finally, Daniel had a really interesting question about something that's still missing, paragraph spacing. He notes that models can infer punctuation, but not paragraph interjection. Why is that? And are there models out there that can do it?
This is a sophisticated challenge, Corn, and it highlights a fundamental distinction in how AI models interpret language. Punctuation, like commas, periods, and question marks, is primarily about local syntactic and semantic cues. A model can learn that certain phrasing, intonation patterns, or word sequences typically precede a question mark, or that a pause often indicates the end of a sentence. This is well within the capabilities of current state-of-the-art language models and speech-to-text systems. They're trained on vast amounts of text and speech where these patterns are explicit.
So it's like learning the grammar rules of spoken language.
Yes, very much like that. However, paragraph interjection is an entirely different beast. It's not about local grammar, it's about higher-level discourse structure, logical breaks in thought, and often the speaker's intent. When a human speaker decides to start a new paragraph, they're typically signaling a shift in topic, a new argument, a different perspective, or a break for readability. These are semantic and structural decisions that go beyond simply recognizing words and their immediate grammatical context.
Wow, so it's not just what did they say, but what do they mean by structuring it this way?
Exactly. And current speech-to-text models, even advanced ones, are primarily focused on the transcription task, converting audio to text accurately. They aren't explicitly trained or architected to infer these deeper, more abstract structural elements of human discourse. While some advanced NLP models can analyze text for discourse structure, integrating that into a real-time speech-to-text system that also predicts when a speaker intends a new paragraph is a significant research frontier. I'm not aware of widely available integrated voice keyboard apps that offer automatic paragraph interjection, as it requires moving beyond transcription to a deeper understanding of communicative intent and tech.
That's fascinating. It really shows how much more complex human communication is than just words on a page. So, for our listeners, what are some practical takeaways from Daniel's deep dive into fine-tuning Whisper and the challenges of voice typing? What can they actually do with this information?
The most significant takeaway for anyone using or considering voice typing is to manage your expectations based on your hardware. If you're primarily on a high-spec desktop, you have the luxury of leveraging larger, more accurate models. For mobile devices, understand that you'll likely be working with smaller, less resource-intensive models, and thus, achieving peak accuracy might require specialized effort. For those interested in fine-tuning, Daniel's experience suggests that even an hour of personal audio can yield noticeable improvements, and up to 5 hours is a solid benchmark for significant gains. Don't underestimate the power of specialized training data, even for smaller models.
So, if you're serious about voice typing, collecting your own voice data and training a model on it is a legitimate path to better results, especially if you're trying to optimize for a specific device.
Precisely. And a broader takeaway, always remember that the utility of a tool dramatically increases at certain accuracy thresholds. Don't settle for mostly right if almost perfect is within reach through fine-tuning or better model selection. The cognitive load of constant correction can quickly negate any speed advantage. Finally, Daniel's question about paragraph spacing highlights where current AI still falls short compared to human understanding. It's a reminder that while AI is brilliant at pattern recognition, it's still evolving in its ability to infer complex human intent and discourse structure. So, if your voice typing doesn't insert paragraphs automatically...
Incredible insights, Herman. Daniel, thank you so much for sending in such a thought-provoking prompt. Your practical experience and detailed questions really allowed us to explore the nuances of speech-to-text technology, from the nuts and bolts of fine-tuning to the philosophical implications of AI understanding human intent. It's clear there's still a lot of exciting development ahead in this space.
Indeed, Corn. The journey from transcribing words to truly understanding and formatting human discourse is a continuous one. We've seen incredible progress, but questions like the optimal amount of training data for highly specific use cases and the development of models that can infer higher-level textual structures like paragraphs remain vibrant areas of research and innovation.
Absolutely. It makes you wonder what our conversations about AI will sound like 5 or 10 years from now. Thank you, Herman, for sharing your expertise. And thank you to all our listeners for tuning into My Weird Prompts. If you want to dive deeper into Daniel's work or explore more of our AI discussions, you can find My Weird Prompts on Spotify and wherever you get your podcasts. We'll catch you next time for another weird prompt.
Bye-bye for now.
Stay curious. Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.